Hi guys. All right, this is in the notes file from yesterday. In your folders, it's called Notes Concavity. I just added the 5.6 because that's what it corresponds to in the CET. So we had talked about all of this stuff. You should have example 1, A and B over here on the left filled out, and example 1 on the right filled out. Okay, I am going to talk about examples 4, 5, and 6 with these graphs, okay, in this video. So example 4, the figure below shows a graph of f prime. This is very important that this is f prime. From -4 to 9, the graph of f prime has a horizontal tangency at 0, so they're telling you there's a horizontal tangency here. Where is the function f concave down, and justify your answer. So when we are looking at the graph of f prime, and once again, it's up to you, but I like to take this and interpret it into kind of like that line graph. Now, this is the line or sign chart or whatever you want to call it for f double prime. Okay, so if you're looking at this, okay, this is f prime. So to figure out what f double prime is going to be, and once again, you can create kind of that parallel analogy, oh my goodness, from f to f prime, okay? If we had a graph of f, this is a total side note, okay, and we wanted to figure out about f prime, we would look at the slopes of f. This is the graph of f. We would say that, the slopes are positive on this region, so that means that f prime would be above the x-axis. And then we would say, here my slopes are negative, so f prime would be negative, which would correspond to values below the x-axis. So let's use a similar analogy here to go from f prime to f double prime. Okay, so if f prime has positive slope right here, okay, so from -4 to -2, we would say that f double prime is then positive. Here you see that it has negative slope, so from -2 to 0, f double prime would be negative. Then from 0 to 2, it would be positive because this has positive slope to it. Then we're negative from 2 to 6 because there's negative slope everywhere there. And then from 6 to 9, we have positive slope. Okay, so the graph of f prime tells us about f double prime, kind of like f tells us stuff about f prime. So if we want to know where this is concave down, that's wherever f double prime is negative. So we would say we're concave down from -2 to 0 and 2 to 6. Now for your justify, okay, they gave us f prime. So I had said yesterday, you kind of want to reference what they give you in your justification. So I would say, come on, because f prime is decreasing, okay? Wherever f prime is decreasing or has negative slope, we are going to be concaving down, and f double prime will be negative. Okay, let's take a look at another one. So here, once again, we have the graph of f prime. It has a horizontal tangency at 7. Find the x-coordinate of each point of inflection and justify. Okay, so once again, I'm going to create a little sign chart here, and this is for f double prime. So if you want to pause the video and try this on your own, by all means, you can do that. Okay, I am going to be looking from -8, you can see, to -2. I have positive slope. F prime is increasing, so that means that f double prime will be positive. Okay, then I have negative slope until we hit 4. So f double prime will be negative. Now, if you notice at 4, okay, at that one specific point, my slope is undefined. Okay, technically it is here too, that's my bad. Okay, but here the slope is undefined. It changed there, so I didn't pay as much attention to it, sorry. Okay, so it will still be negative from 4 to 7. Okay, because the slope is still negative there. And then from 7 to 10, we have positive slope. Okay, and then from 10 to 15, we have negative slope. Okay, so the key thing we had said yesterday, okay, for a point of inflection to occur, the concavity has to change from concave up to down or down to up. If it stays the same, it is not an actual point of inflection. So when we look here, it just wants the x-coordinates of the points of inflection. So you can see we have one at -2 because here we change from concave up to concave down. We have another one here at 7 and then at 10. And our justification would be because f prime, because they gave us f prime, changes from increasing to decreasing or vice versa. You could say that f double prime changes signs at those locations, but you're better off referring to what they give you. Since they gave us f prime, I'm going to refer to that. All right, try the last one here. So once again, graph of f prime. They want to know where is it both decreasing and concave up. Okay, so we're looking at two different things here. So I'm going to create two different sign charts here. One for f prime and one for f double prime. So I'm going to focus on f prime first. So for f prime, okay, where it crosses the x-axis is my critical points. So at -2, I guess I should space these out a little bit better. It's my bad. Okay, so -2, 4, and 7. Sorry, it just keeps jumping and freezing. Now it's frozen. Okay, so we're below the x-axis leading up to -2. So, oh my gosh, so this is negative. Then we're above the x-axis for f prime, so that means f prime's positive, or the slope's positive, aka f is increasing, so that's positive. Then we're below, so that's negative, and then we're above, so that's positive. Okay. Now for f double prime, I'm going to change colors here. Do this all in blue. Okay, for f double prime, we're looking at the slopes of this. So here we have positive slopes. So up until 0, I have positive slopes, so f double prime would be positive. Then I have negative slope all the way to 6. Okay, so f double prime will be negative. And then I have positive slopes to 8. And then I have negative slopes to 10. I should have lined these up a little bit better, but it's fine. So we want to know where we're both decreasing. So that would be where f prime is negative and concave up. That's where f double prime is positive. So if you look, we're looking for a region where we're both negative and for f prime and positive for f double prime. So here we're negative and positive. We're negative from 4 to 7, but we're only positive from 6. So just this little section here. Okay, so let's write those intervals. So we are, f is decreasing and concave up from -infinity to -2. Oh, excuse me, not negative infinity. Sorry, the graph starts at -4. So -4 to -2, that's my bad. And then also from 6 to 7. Because f prime of x is less than 0 and f prime of x is increasing on those intervals. So in both of those rationales, I referred to f prime because that's what I was given. Okay? All right, guys. Mark down any questions that you might have. We can clearly talk about all of this more tomorrow.